Hi, I'm Rute, and today I'm going to present my latest work on augmented interfaces to minimize latency impact in the context of lunar exploration. So, rovers on the lunar surface can be teleoperated from Earth with a latency of approximately 3 seconds, which gives us an opportunity to directly control a rover from Earth while adding human cognition and decision making to the control loop. However, such an approach means that every time the operator sends a command, they must wait 3 seconds to see the feedback of the resulting action. This often leads to overshooting goals, high rates of collisions, and high levels of human cognitive workload. To minimize these negative effects, we have implemented and tested 3 augmented teleoperation interfaces that are immediately reactive to the operator's commands. The first one we named predictive interface, and the operator can directly control the rover while having augmented on the image and map a prediction of the path the rover will take in the next 3 seconds and its final position. The second one is the avatar-aided interface, where the operator does not directly control the robot, but instead controls this avatar that is augmented on the image and again on the map. And this avatar then represents a navigation goal which the rover will continuously try to follow by resorting to autonomy algorithms on board the robot. And finally, we created this hybrid interface where the operators can change between the predictive and avatar approach whenever they need. To evaluate these interfaces, we performed a systematic user study where we recruited 30 volunteers that performed 4 experimental conditions each, including the presented interfaces and the control interface where no information was augmented on the image. All participants performed a search and inspection task within a simulated environment with traction losses. Our preliminary results compare the control, predictive, and avatar interfaces. And we can see here on this first graph concerning workload that using the avatar-aided interface significantly reduced the operator's workload when compared to the control interface. When we look at the number of collisions, we verify that when using the avatar-aided interface, the participants perform significantly less collisions than when using the control and the predictive interface. Regarding usability, the data show that avatar interface was easier to use than the control and the predictive interface. And we also verified that 13% of our participants tipped over the robot during the task while using the control and the predictive interface. So, to conclude, the predictive interface did not show significant improvements in the analyzed metrics, which showed us that such an approach is not enough when traction losses are common, because this often leads to a different final position than the prediction indicated. Second, the avatar-aided interface showed improvements in rover safety and lower workload. And finally, the participants reported that the hybrid interface allowed to cope with the limitations of both predictive and avatar-aided interface by switching between these during non-nominal events.